Hello everyone and welcome back to Chemistry with Kenny. We are continuing our series looking at the GCSE Physics spec. Now we're going to be working through the whole spec, so make sure you do subscribe to see all of those videos. Today we are going to be looking at calculating momentum. Now this is a triple only section. However, if you are on double award and want to do A-level physics, this is useful, so please do stick around. First of all, we're going to define momentum. So momentum is the big question. Now, the way I always like to think of momentum is the ability for an object to keep moving. There's loads of situations you can think of. The one that always goes to my head is either a rugby player or an NFL player running at somebody. If they have higher momentum than the other person, they're going to knock them over and keep moving. If the other person has high momentum, they're going to get knocked over and they're going to stop moving. This is really, really important. Now, to make this easier for us, there is an equation that goes along with it, which is P equals mv. So if you think about those rugby players or those NFL players, the person with the bigger mass is harder to stop. The person that is traveling faster is harder to stop. So that's why we have momentum, and that's why we have velocity. Okay, both really important parts when we look at momentum. Just to look at those letters, because they are a little bit confusing, or one of them is. This P is actually our symbol for momentum. Okay, M is our symbol for mass, V being our symbol for velocity. So now if we think about our units, mass we know should always be in kilograms, velocity should be in meters per second, which means momentum is in kilogram meters per second. And that's our unit for momentum. This does go into a formula triangle. Now, I'm not a huge fan of formula triangles, but I know people are. It's got P at the top, got M, and we got V. Got our times line here, and our divide lines. Once again, you cover up the one that you want, and it kind of leaves you with the triangle or the formula that you need. So, let's just have a go at calculating momentum first, and then we'll move on to something slightly more complex. Now, calculate the momentum of a 750 kilogram car traveling at a velocity of 25 meters per second. So, first of all, we need to identify our mass. Our mass here, that's not the best pen to use, but our mass here, 750 kilograms. Our velocity, we got down here, we'll put our mass. Our velocity is 25 meters per second. So we always write our equation, P equals mv, identify our variables, mv, we don't know that one, mass 750 kilograms, and our velocity, as we got from the question, 25 meters per second. So then it's as simple as looking at our calculator, and we're going to do P equals 750 times 25. So P equals 750 times 25, 18,750 kilogram meters per second. Now that we've had a go at calculating momentum, let's move on to a really important concept, which is the conservation of momentum. Now this is super simple to understand. The total momentum before is equal to the total momentum after. So if we think about our rugby players, NFL players, the total momentum of player A and player B before they hit each other is equal to the total momentum after they hit each other. Momentum is always conserved. So what that looks like in an actual exam question is this below. Okay, it's a little bit hard for me to fit that all on the screen. Let's move that out the way. So state the total momentum of glider A and glider B after the collision. So this picture here is a before the collision, and we can see, I'll just change the color of this, glider A has a momentum of 0.0, let's actually write that down, 0.045 kilogram meters per second, and glider B is at rest, so it's 0, which means the total momentum after the collision must be equal to that, which is 0.045 kilogram meters per second. So after the collision, the momentum of glider A is 0.021 kilogram meters per second to the left. Calculate the momentum of glider B. So if we know A plus B must be 0.045, and we're talking about to the left at the moment, if we look back up here, this is to the right, which means to the left must be a negative number. So we've got negative 0.021 plus B equals 0.045. Then we know B must equal 0.045 plus 0.021. Now the reason I know that's negative is we're using velocity to find momentum, which means momentum itself is a vector quantity, which means it has direction associated to it. So if we were already going to the right and we knew that was the positive direction, it means anything to the left must be the negative direction. So then here we know B equals 0.066 kilogram meters per second. And that is basics of calculating momentum. Now download the worksheet from the website and you'll get all of these practice questions along with there. It's completely free to download. Head over to the link in the description.